Fourier integral. In this article, we will try to represent the Fourier in the integral form. So let us suppose a function is there, function fx is there, which satisfies the Distt conditions. So this function can be written as fx is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x by l and plus bn sine of n pi x by l. Right. Uh, Here a0 can be written as 1 by l minus l2 plus l ft dt. Similarly, an, this an can be written as 1 by l minus l2 plus l ft cos of n pi t l by l dt, and similarly bn is equal to this one. Now putting the value of a0, an, bn here. Here you have to put the value. So this relationship can be written as fx is equal to 1 by 2 pi, 1 by 2l, sorry, because L, 1 by L is there, 2 L is here, so 1 by 2l and minus L2 plus L ft dt. Because a0 by 2 is there, mean basically 1 by 2l we have to write here in that way. Similarly, we can write the value of this an here and we can put the value of bn here. So this formula will be there. Then you can see here 1 by l here, 1 by l here, ft dt here. So you can take this 1 by l and ft dt as a common. Further, so this same relation I have copied. So you can see this equation basically is a cos of a minus b formula. So fx is equal to, we can write 1 by 2l ft dt plus 1 by l and summation minus l2 plus l, the same thing here, ft dt and 1 by l, and this formula will be, this whole equation we can write as cos of a minus b, and this is a and this is b divided by l, right? Because l is common here also, so we can write. So you can see here now we can take n pi by l common, so t minus s will be there, other part will be same. Now you can put, because n pi by l is there, so I have deliberately taken out so that I can write as alpha constant quantity, and so I have to find the value of dl alpha, that will be alpha n plus 1 minus alpha n. So alpha n plus 1 minus alpha n will be, you can put all the values simply and you can see, put the value here, right, and put it will be alpha n plus n will be n plus 1 pi by l and minus n alpha, so sorry, alpha n will be this one. So basically d alpha will be equal to pi by l. So that simply we can write now fx as such 1 by 2l ft dt plus this because pi by l is there, this pi by l, that is basically d alpha, right? So plus pi and this I have divided and multiply so that it can be written in this form. So pi by l pi, you can see 1 by l is there, only 1 by l is there. So I have changed by multiplying by pi and divided by pi, nothing else. So summation n is equal to 1 to infinity, the same formula, nothing changes there. Only thing is I have replaced this formula, this n pi by l as alpha n. That's why I have written here also. So alpha n also there, and this I have changed this form deliberately by multiplying and divided by pi. So this form will be there. No, fx is equal to 1 by 2l ft dt. This same formula copied, nothing else. And here d alpha will be equal to pi l, that we already calculated from the question 5. So that from there we can copy it here. This pi by l is there. Now, as we know, as l tend to infinity, as per the Distt condition, 1 by l will be equal to 10 to 0. So this will be 0. So this part will be basically 0, 10 to 0. So what is left is fx is equal to limit, we have taken the limit as L tend to infinity. So same here. So what I left is 1 by pi on left, because this pi by L I have taken inside, right? Because this integral L is there, minus L to plus L, so that one taken inside. So pi by L here, right? So what will happen is, as the limit L tend to infinity, this summation will change to the integral that I have already discussed with you. So this summation will change. So accordingly, I have changed the the summation to integral, so that you can see. So fx is equal to what? 1 by pi as such, summation, right? And equal to 1 to infinity will be changed to 0 to infinity, and this minus L to plus L will be minus infinity to plus infinity. So alpha ft cos of f, this formula same thing, and this pi by L I have already represented at d alpha. I have calculated, put up this value here. So that is the Fourier integral formula. Thank you.